Now that we have our scatter source set up, we can start setting up the RBD sim for this debris. Now, a lot of this RBD sim will be the same as we've set it up for our previous simulations. We already have some velocity on these debris chunks that we've inherited from the main RBD sim, but we don't have any angular velocity yet, so I'll add another attribute randomize to add some random W. I'll connect our scattered instances to that, set the min and max to -1 and 1 for x, y, and z, and I'll set the global scale to 10, and the attribute name will be W. And then I'm going to also set up our usual sim attributes point wrangle. So I'll drop that in and rename it. And as usual, you can set up your Excel limits and speed limits and everything in here, the same as a normal RBD sim. And because we have velocities that we want to read into the simulation on every frame, we need to set all of these pieces as animated so that it always picks up those initial velocities. So we'll set animated is equal to 1, and we'll also need to set some unique names on these pieces. So if you middle mouse on this sim attributes wrangle, you'll see we have over 1,000 pieces, but only 30 different names because they're each inheriting the name of their original debris piece. Now we still want to store that original name, so I'm going to add a new attribute called name_orig, and we'll set that equal to the existing name. And then we'll set a unique name for each of these pieces. Now to set these unique names, we'll set that equal to debris underscore and then the frame number, and then we'll also tack on the point number. So if you middle mouse on this now, you can see our new name attribute has 1,296 unique values, which matches our 1,296 fragments. And before we sim this, I'm just going to add an Excel max and angular Excel max, both set to 50, just to avoid any massive stray impulses that sometimes happen. And you can set any other attributes on here that you think might be helpful later. For example, I'm also going to set some rest data so that we know where each of these debris pieces was originally emitted from. And then we'll start putting together our DOP-net. Now I'm just going to wire our debris source directly into that DOP-net. And then inside the DOP-net, you can create two RBD packed objects, one for the debris and one for our collider RBD sim. And we'll merge those together, wire that into a bullet solver, attach a ground plane and gravity. And then to bring in those colliders, I'm going to object merge that RBD sim from above. So I'll point this object merge to ... /RBD. That's the null right after the simulation up here. And these RBD objects are coming in with a lot of attributes from their original simulation. And some of these might affect our debris sim in unexpected ways. So I'm just going to delete all of those. So drop in an attribute delete, put a star in the point attributes. Although we don't want to remove the name, so I will omit the name from that attribute deletion. So you can see it's gotten rid of all those point attributes except for the name. Then I'll attach that to the second input of our DOP-net. Then I'll go back inside, tell this collider object to use the second context geometry as its source, and we'll set that type to animated static objects. And for the RBD packed object debris, we'll point that to the first context geometry and turn on inherit velocity from point velocity. Now if we rewind to the beginning of the simulation, you'll see it's creating debris pieces while this wall is still intact. So you could do a couple things. You could modify the source to only emit from moving pieces based on their velocity from that RBD sim. We could also, in this case, just delay the emission by 1 frame. So for this example, I'll just do that. Go to the DOP-net settings, simulation, and I'll set that start frame to 986. And then I'll display that DOP-net and go back inside. And now it won't start emitting until those pieces start to split apart. And now we're all set to run a flipbook and see what this looks like. So if you take a look at this flipbook, this is looking pretty cool. We've got some very nice, interesting detail being added by this debris. There are still some issues in here. A lot of the small pieces are rolling around a bit unrealistically. And right now, all of those debris pieces are inheriting 100% of the motion from the pieces. And usually it looks better for the debris to only inherit a percentage of the original piece velocity. So on your sim attributes wrangle, you can add a velocity multiplier before the sim. Oftentimes I'll use maybe 50% as a starting multiplier on the velocity. So I'll type v at v times equals 0.5. And to reduce some of these small pieces rolling around, we can fix the collision geometry to be a bit more accurate. So let's go to the first frame of the sim and dive inside the DOPNet, and we'll go to that RBD packed object for the colliders and turn off the display geometry for the moment, and then zoom in on these emitted debris pieces. Now if you select the RBD packed object for the debris and go to the bullet data, there are some options here for the collision padding. So let's turn on show guide geometry to see what these colliders look like. And if you zoom in, you can see that for larger pieces, the collision geometry probably gives us a pretty close representation. But for some of the smaller ones in particular, this built-in default collision padding and shrinking is kind of rounding out and approximating that shape too much. So let's see if we can find a good example piece here. Maybe one of these pieces over here. You can see those collision shapes are pretty rounded out there. So you could reduce this collision padding and shrink amount. So if I set that to 0.005, you can see it's getting much more accurate. We could even try setting it completely to 0. And that should give us some more accurate collision shapes. Normally you don't have to mess with this too much in most of your RBD sims, at least when you're dealing with bigger pieces, but when you get into pretty tiny pieces, this is a common problem. Now if we re-simulate this with that new velocity multiplier and the updated collision shapes, you can see we're getting much better collisions with the ground, although that new velocity is not nearly energetic enough. So maybe we'll try a value of more like 0.9 for that multiplier. But the other problem here is that we're only getting debris emission on the very first frame. We set up a scatter to emit debris for multiple frames, and it's only the stuff from the first frame that we're seeing in this sim. And this is also looking like a fair amount of debris already. So if we're going to emit for multiple frames, then we should turn down our scatter density. So let's go back to those sim attributes. I'll try an inheritance of 90%. And on this scatter, let's turn this down to, I don't know, we'll try a value of 3 to see what that looks like. And emitting from 985 to 1010 might be a bit long for the emission on this. So let's reduce that emission range so that it's done emitting by frame 995. And now to implement that per frame emission in the solver, you can go to this RBD packed object for the debris, and there's a little hack we can use on this creation frame so that it's always creating new pieces as it sees them in SOPs. By default, this creation frame is just wired to the start frame of our sim. So if you Control-Shift-click that to get rid of that expression, and then type in $F for the current frame, then this is going to create new pieces of debris on every frame of our sim. So now with that creation enabled on every frame, if you step through the sim, you should see new pieces being born on subsequent frames. Now after turning on continuous emission in our simulation and raising that velocity multiplier, things are looking much better.